This video talks about radian measure, which is another way to measure an angle. And radian measures something that is an angle, it's not a distance. So we call the radian measure of an angle theta the length of the arc that subtends the angle divided by the radius of the circle. Now what that looks like is if we have a distance here, that is r, our radius. We have a second distance here. This is also r because it's part of our circle. The 1 radian is when this arc length here is equal to the radius. If I had, well, it looks like it might be here, another arc length up here, this would be, this whole distance, that would be 2 radians if this arc length was equal to 2 times the radius. So for complete revolutions, for theta equals 360, the length of the arc is equal to 2 pi r, which is the circumference of that circle. Some circumference. So 2 things that you do need to know are how to go from radians to degrees. So in this case, you take the number of radians and you multiply by 180 over pi. And if you're going from degrees to radians, you're going to take the number of degrees and you're going to multiply by pi over 180. So 1 radian is about 180 degrees over pi, and then 1 degree is pi over 180. These values here are just ballpark values. Don't use them in any sort of calculation, just an estimate. In terms of notation, often we don't write rad or radian. An angle with a degree symbol is a degrees. Something that doesn't have any symbols beside it is just said to be in radians. So exact angles in radians are usually written in terms of pi. So the first 2 examples we're going to do are an exact and an approximate radian measure of the following. So 30 degrees, in order to go from degrees to radian, we're going to multiply by pi over 180. I can reduce that before I multiply by dividing the top and the bottom by 30. It's going to leave me with 6, which means that my exact angle is pi over 6, and using my calculator, that comes out to about 0.524. 45 degrees, we can do the same way. We're going to multiply by pi over 180. I can reduce here before I multiply through, and I'm left with pi over 4, or about 0.785. The next 2 are going in the opposite direction. So I'm going to take my radian measure and I'm going to multiply by 180 over pi. I can cancel the pi's. I'm left with 180 over 3, which is going to simplify to 60 degrees. And then my second angle, I've got 5.86 radians. I'm going to multiply by 180 over pi, which works out to about 336 degrees. We'll round to the nearest degree. The next question is about measuring the arc length. So the arc length, which we denoted as A above, so we'll say A, is going to be the radius times the angle that it passes through. So the horse carousel goes around like this. Horse is 9 meters. That's our radius. And then it travels through an angle of 5 pi over 6, and we're looking for the length of the arc here. So we're going to take our radius, which is 9, and we're going to multiply by the angle that it travels through. And we're going to be left with 15 pi over 2 as our arc length. If you're interested in the derivation of that formula, we can go through it at another time, but this is how you calculate the arc length. The last one is some work with units. We're just changing 7,200 rotations per minute into degrees per second and then radians per second. So I'm going to start, I've got 7,200 rotations per minute. And now what I'm going to multiply and divide by is depending on my units. So I know that I've got 360 degrees in one rotation. That is going to allow me to cancel out those units. And then I'm going to change minutes into seconds. So I know that in 1 minute, I have 60 seconds. That's going to allow me to cross out my minute units. And then multiplying 7,200 by 360 and dividing by 60 seconds is going to give me 43,200 degrees per second. To change that into radians, I'm going to take 43,200 degrees per second, and I'm going to multiply by pi over 180 degrees. That's going to let me cross out my degrees and be left with radians. And I can simplify that to an exact answer as 240 pi radians per second. And though that is what a radian is and how you change between degrees and radians.